Welcome. In this session, we'll learn the open and short circuit behavior of a capacitor in an RC circuit. Let's start. So in the previous session, we learned the behavior of the RC circuit when we connect a source to this capacitor. So let me redraw that RC circuit. So this is the RC circuit. So we are connecting a source at t equal to 0 to this RC circuit. And our goal is to observe the voltage across the capacitor and current through this capacitor. In the previous sessions, we learned what is the VC across this capacitor will be equal to simply Vs 1 minus e to the power of t by tau, where tau is the time constant of this circuit, that's equal to RC. Similarly, the current that flows in this capacitor is simply Vs by R e to the power of minus t by tau. Again, tau is the time constant of this circuit. So this is the behavior of the capacitor voltage and capacitor current when we connect a source to this RC network. All right. Now, what we are going to do, well, we check the value of the voltage and current at t equal to 0. So at t equal to 0, what's the value of the voltage? You can see Vc of 0 is equal to 0 because this quantity is 1. So 1 minus 1, it will be 0. And the current at t equal to 0 will be simply Vs by R because this exponent will be simply equal to 1. Right? So what is happening at t equal to 0 when you connect a source in an initially relaxed RC system or RC network? Initially relaxed means when the initial voltage stored in the capacitor is 0. So what is happening to that capacitor? Now you can see the voltage across the capacitor is 0, but the current is flowing. So there is current, but there is no voltage. So this element is behaving like a short circuit. So at t equal to 0, the element is behaving like a short circuit. You can have a look at this. So the element at t equal to 0 is behaving like a short circuit. All right, this is very, very important observation. All right, now next, at t equal to infinity means when time reaches to when time is equal to 5 time constant, simply we can say at t equal to infinity. All right. So when time is equal to infinity, what will happen to the voltage? Vc of infinity means final value. Actually, we should take it equal to 5 time constants. That's what we have assumed from the previous session. It achieves the last value in final value in 5 time constant. Right? Let us now do that. Let's use the final. Let's use t equal to infinity. So in t equal to infinity, what's the value of this quantity? This will be 0. So we are left with Vs. And what will happen to the current? IC of infinity from this quantity, you can see this quantity is 0, so 0 multiplied by this is 0, so IC will be 0. You can have a look at this circuit. Now pay attention to these quantities. At t equal to infinity, the voltage across this is Vs. So on one side of this resistor, we have Vs. On other side, we have also Vs. So how much is the current flowing through this resistor? It is 0. That's again shown by this because R and C are in series. So the current is 0. Now, when will the current through an element be 0? If the current is and if the circuit is open circuit, means at t equal to infinity, the circuit is behaving like an open circuit. So circuit is behaving like an open circuit at t equal to infinity. All right. So at t equal to infinity, the circuit is behaving like an open circuit. Now, please pay attention to the next point. Now, what does it mean? Does it open? Does these two plates separate? Does it mean that open? Is it opening by that logic? No. In other words, it's acquiring the final full value of this supply voltage, means the capacitor is now fully charged. At this time, the capacitor is fully charged. And when it acquires that state, means when it acquires the full state, full value of the input, we say capacitor is open now. Capacitor is open now. So in the at t equal to infinity, the capacitor behaves like an open circuit, and at t equal to 0, the capacitor behaves like a short circuit. All right, this is very, very important. Now, in the previous sessions, we said the capacitor acquires this voltage. Capacitor acquires this voltage at t equal to 5 time constants only, right? We assume approximately it acquires the voltage in 5 time constants. We can say in steady state, then the capacitor actually behaves as an open circuit. So in steady state only, we can say the capacitor behaves like an open circuit. So this is also valid for that state, because the capacitor acquires the value actually in 5 time constants, and after 5 time constants we have assumed in the previous session that it's in steady state. That means in steady state the capacitor behaves like an open circuit. Again, I am going to repeat, it does not open. The pallet two pallets do not separate. Open here simply means it has acquired the full value. Now the current will stop flowing. In that sense, the capacitor behaves like an open circuit. All right. Okay, I hope you have got the idea. Now, how does it behave like an open circuit and how it behaves like a short circuit? Right, when you turn on the switch. All right. Okay, let me end this session here.